Lightning is a discharge of electricity. A single stroke of lightning can heat the air around it to 30,000 Celsius, 54,000 Fahrenheit. This extreme heating causes the air to expand explosively fast. The expansion creates a shock wave that turns into a booming sound wave, known as thunder. In fact, lightning can heat the air it passes through to 50,000 degrees Fahrenheit. It is 5 times hotter than the surface of the sun. Lightning often strikes water, and water conducts electricity. That means that the currents from a lightning strike can seriously injure you. In fact, it can even kill you. This is why, when you hear thunder or see lightning, it's a good idea to avoid the pool, beach, and any other large body of water. Sometimes can only hear thunder without lightning. Lightning may be seen but there is no thunder heard. This is either because thunder is rarely heard more than 20 km away or because the atmospheric conditions lead to sound bending upwards and away from the surface. Thunder is caused by lightning. When a lightning bolt travels from the cloud to the ground, it actually opens up a little hole in the air, called a channel. Once then light is gone, the air collapses back in and creates a sound wave that we hear as thunder. No, it is not possible to have thunder without lightning. Thunder starts as a shock wave from the explosively expanding lightning channel when a large current causes rapid heating. However, it is possible that you might see lightning and not hear the thunder because it was too far away. Thunder is caused by lightning. Sometimes you can see lightning but not hear thunder. Thunder is a direct result of lightning. If you see lightning but don't hear thunder, it is because the thunder is too far away. Sometimes, people refer to this as heat lightning because it most often occurs in the summer. But it is no different from regular lighting. What does it mean when thunder is really loud? Sometimes you hear a big noise of thunder so loud. It's because the amount of electrical energy that flows from the cloud to the ground is so enormous it's like a very big waterfall of electricity. The louder the sound that you hear, the closer you are to the lightning. Light travels through air much faster than sound. The causes of lightning, that thunder clouds have rubber shoes. Not exactly, but there is a lot of shuffling going on inside the cloud. Animation shows icy particles coming down and water droplets rising in a cloud, rubbing against each other, creating negative and positive charges. The thunder causes by the rapid expansion of the air surrounding the path of a lightning bolt. The grumbles and growls we hear in thunderstorms actually come from the rapid expansion of the air surrounding the lightning bolt. Lightning is a naturally occurring electrostatic discharge during which two electrically charged regions in the atmosphere or ground temporarily equalize themselves, causing the instantaneous release of as much as 1 gigajoule of energy. The life of a typical non-severe thunderstorm goes through 3 stages: cumulus, mature, and dissipating. We see the cloud that will become the thunderstorm starting to form and grow due to the rising thermal or updraft. Lightning is 4 times hotter than the sun. A return stroke of lightning, that is, a bolt shooting up from the ground in a cloud, after a stream of electricity came downward from a cloud, can peak at 50,000 degrees Fahrenheit. The surface of the sun is around 11,000 degrees Fahrenheit. Likely you just touched a metal doorknob after shuffling your rubber-soled feet across the carpet. You've been struck by lightning. Well, not really, but it's the same idea. Your rubber-soled shoes picked up stray electrons from the carpet. Those electrons build up on your shoes, giving them a static charge. Static charges are always looking for the first opportunity to escape, or discharge. Your contact with the metal doorknob or car handle or anything that conducts electricity presents that opportunity, and the excess electrons jump at the chance. Lightning begins as static charges in a rain cloud. Winds inside the cloud are very turbulent. Water droplets in the bottom part of the cloud are caught in the updrafts and lifted to great heights, where the much colder atmosphere freezes them. Meanwhile, downdrafts in the cloud push ice and hail down from the top of the cloud. Where the ice going down meets the water coming up, electrons are stripped off. There are 6 types of lightning. Cloud-to-ground lightning. Negative cloud-to-ground lightning. Positive cloud-to-ground lightning. Cloud-to-air lightning. Ground-to-cloud lightning. Intra-cloud lightning. It's a little more complicated than that, but what results is a cloud with a negatively charged bottom and a positively charged top. These electrical fields become incredibly strong, with the atmosphere acting as an insulator between them in the cloud. When the strength of the charge overpowers the insulating properties of the atmosphere, ops lightning happens. The electric field looks for a doorknob. Sort of. It looks for the closest and easiest path to release its charge. Often lightning occurs between clouds or inside a cloud. But the lightning we usually care about most is the lightning that goes from clouds to ground, because that's us. Animated image shows lightning branches spreading out very slowly toward the ground, then, once the ground is touched, a bright stroke travels up to the cloud and it flickers even more brightly a couple of times. As the storm moves over the ground, the strong negative charge in the cloud attracts positive charges in the ground. These positive charges move up into the tallest objects like trees, telephone poles, and houses. A step leader of negative charge descends from the cloud seeking out a path toward the ground. Although this phase of a lightning strike is too rapid for human eyes, this slow motion video shows it happening. As the negative charge gets close to the ground, a positive charge, called a streamer, reaches up to meet the negative charge. The channels connect and we see the lightning stroke. We may see several strokes using the same path, giving the lightning bolt a flickering appearance, before the electrical discharge is complete. Still image from animated drawing showing lightning descending from cloud and positively charged streamers reaching up from tall objects on the ground. In a fraction of a second, lightning heats the air around it to incredible temperatures as hot as 54,000 degrees Fahrenheit, 30,000 degrees Celsius. That's 5 times hotter than the surface of the sun. The heated air expands explosively, creating a shock wave as the surrounding air is rapidly compressed. The air then contracts rapidly as it cools. This creates an initial crack sound, followed by rumbles as the column of air continues to vibrate. If we are watching the sky, we see the lightning before we hear the thunder. That is because light travels much faster than sound waves. We can estimate the distance of the lightning by counting how many seconds it takes until we hear the thunder. It takes approximately 5 seconds for the sound to travel 1 mile. If the thunder follows the lightning almost instantly, you know the lightning is too close for comfort. Thunder is caused by lightning. The bright light of the lightning flash caused by the return stroke mentioned above represents a great deal of energy. This energy heats the air in the channel to above 50,000 degrees Fahrenheit in only a few millionths of a second. Most of us are familiar with thunderstorms and the lightning and thunder that accompany them. However, most of us aren't all that familiar with how thunder and lightning are produced in a thunderstorm. Put simply, lightning is a result of electrons moving between the clouds and the ground, and thunder comes as a result of lightning. Lightning look-like from space observed by the GO-16 geostationary lightning mapper illuminates the storms developing over in southeast Texas. Lightning is an important part of weather forecasting. The geostationary lightning mapper instrument on the GOES-R series satellites can detect lightning activity over nearly the whole western hemisphere. Scientists use data from GOES-R series satellites, along with data from the lightning imaging sensor on NASA's Tropical Rainfall Measuring Mission satellite, to study lightning. This complete picture of lightning at any given time will improve. Nowcasting of dangerous thunderstorms, tornadoes, hail, and flash floods. However, thunderstorms and lightning are related. Most of us are familiar with thunderstorms and the lightning and thunder that accompany them. However, most of us aren't all that familiar with how thunder and lightning are produced in a thunderstorm. Put simply, lightning is a result of electrons moving between the clouds and the ground, and thunder comes as a result of lightning. Scientists are still trying to work out exactly how lightning forms, but we know it has something to do with the interactions. between positive and negatively charged ions within clouds. If you've ever walked across a carpet and then touched a doorknob only to get shocked, you've experienced a discharge of static electricity. Your movement across the floor generated a static non-moving electric charge, which looks for this first possible opportunity to escape and discharge. The same thing happens with lightning inside clouds, just on a much larger scale. The crystals of ice and water that constitute clouds are water molecules, and during a storm the air moves these particles around, making them collide. According to some current theories on lightning formation, the negatively charged electrons from the upward moving molecules of water are transferred to the heavier molecules that are moving downward. This situation means that the top of the storm cloud is positively charged and the bottom of the storm cloud is more negatively charged.